Thanks, Brian. Hey, everyone. Thanks for coming. Thank you for coming out in terrible, terrible weather. It's nice to see all these people here. Yeah, I'm talking about event sourcing today. Event sourcing is a design pattern that some of you may or may not have heard of. I recently used it inside of Rails. It doesn't fit perfectly inside of Rails, so I'm going to talk about sort of nuts and bolts and trade-offs. The reason I started with all this was basically over the summer I was working with a company that did a subscription service. We sold coffee. By the way, raise your hand if you work on a subscription service right now. Okay, all right, some of you, yeah, right? Like this is, New York has a lot of them. Recurring subscription services, recurrence logic is actually surprisingly complicated, right? You have recurring shipments, you have recurring payments, maybe you get holds which push back the ship date, maybe you get suspensions. We were dealing with a lot of problems, and basically the situation was that I had, when I came on board, there was an existing subscription model that had been written by somebody who wasn't given enough time, and business, sort of business logic kind of kept on thrashing around, and so the model itself bore a lot of scars. So I was routinely debugging, and I was constantly asking myself, how did this record get in its current state? You always got some customer service problem, some subscription or some record makes no sense at all, someone just spent $200 and they're pissed, right? And it's really hard, actually, if you do it wrong, it's hard to know which code led to the change, right? There's a bunch of different ways a record could change, and maybe you don't have a good actual record of how the record changed. Its previous data might be overwritten, so you don't necessarily know where you were before you got to the wrong place. You don't know where the problem even started in the sort of stream of changes. And the relevant code itself might not exist. And this is the worst of all. But sometimes you see something where literally the updated at field on this record is 3 months old, and you know that you don't even have the current code, the code that worked out in that time period. And this sucks, basically, right? It makes you end up feeling a lot less like this Keanu Reeves, and a lot more like that Keanu Reeves. So I had a lot of this going on, and I was very frustrated. In a similar sense, there's also this issue about reporting, which is actually kind of another angle on the same problem. Reporting is time-based, and if you've ever been asked by anyone in the business to do reporting, it's all about, well, what was churn as of a year ago? What's the LTV? All these things. What was the state of this person at some point in the past? It turns out that Rails programming, and a lot of web programming, is all about, let's make sure this record is in the right place right now. Right? And then you always get into the situation where you're sort of backstepping, and you're like, oh, I didn't know you wanted that. Well, you know what? It turns out they actually always wanted it. They were just like too nice to ask for it right off the start. So I was I've been reading about this model, this design pattern called event sourcing, which Martin Fowler writes down. It's not even that new. It's from like 2005. And I wanted to give it a try. Roughly speaking, my interpretation of event sourcing is that this core data is time-based immutable events, which is to say, we observe that this thing happens in time, you timestamp it, and you don't really, immutable meaning you probably don't change it later after the fact, right? And then you have the deterministic idempotent code that calculates state, which is to say, it's deterministic meaning if you run it twice in a row, it will always return the same result. And it's idempotent, this is super important in object orientation land, it's idempotent meaning you can run it twice in a row, it won't fire off anything you don't want to fire off twice. And then generated entities, in this case the description, are actually just caches. They're actually just a local calculated state that you saved. So we were changing a lot of the business model, and I had a good opportunity. We were going to have to write a bunch of new code anyway, and I had a good opportunity to say, hey, let's make a run for the border and let's see how this event sourcing thing works out. One of the things, by the way, who here has used the gem paper trail, the Ruby gem? Okay, some of you know about this. This has a funny echo with paper trail, but it's worth noting the differences. There's a similar time-based log of changes. For those of you who don't know, paper trail is a thing that you hook into active record, and every time you save a change to that record into the database, it persists a record of like, oh, at this time something was changed. But event sourcing defines events more precisely. Usually you are asked to upfront say, I'm not just recording a change, I'm recording a creation, a cancellation, a shipment. And then events come first, not last, which is to say the events are the most important piece of data, and the subscription itself is a cache. So let's look at some code. Let's show you what I'm talking about. So we'll start with creation, right? Let's say you work at a subscription service that sells bottles of shampoo in the mail. This is a terrible idea for a startup, but it's not the worst. And let's say these are your two models you're dealing with. You've got a subscription. For now, you need it to support bottles per shipment. That's a number, user ID, because it needs to be connected to a user, and the number of bottles left, right? You paid for some amount of bottles, you're going to get some left at some point in the future. And then you have a subscription event, right? So subscription ID, it's connected to the subscription event. It belongs to a subscription. Event type, that's something like creation, cancellations, whatever. Data, that's the way I was doing it. It was just a serialized JSON hash, and then created at. Created at, of course, is always on an active record, but it's super important here, and you'll see why. During creation, this is one way that you could do it. This is what the code looked like. You do a new subscription. The creation, actually, there's this funny object creational stuff that I'll come back to later. It gets actually really complicated. But then you build a subscription event with an event type of creation. You pass data, right? It's a hash. Bottles per shipment, bottles purchased, user ID. Down here, you pass the subscription into a subscription calculator object. You call .run, you get a result, and you save it to the database. What's going on inside the subscription is pretty simple, actually. During the run method, it looks for all the events attached to that subscription and sorts them by creation time. And it runs them using that self-send advanced underscore event type. That's like the lovely dynamic stuff you get out of Ruby. So you're kind of setting yourself up to say, whatever kind of event type there is, I need to have a method called advanced underscore whatever, right? And you run it on the subscription. In this case, you got advanced underscore creation. You're setting the user ID, you're setting the bottles per shipment, you're setting the bottles left. It is worth noting right here, and this is where things start to get a little interesting, is that it's not bottles purchased that you're storing on the subscription, you're storing the bottles left. As we go on, we'll be incrementing and decrementing that number based on events in the domain. Change settings is actually pretty prosaic, but you're going to have that too. Let's say somebody wants to increase or decrease the number of bottles per shipment they get. So you have an existing subscription in the controller, you just get it based on an ID. And then you create a brand new event called change settings, and then you say, oh, the bottles per shipment is now updated to this number. And then you run the calculator. Inside the calculator, you add one more method, advanced change settings, and you just set the bottles per shipment. I want to be clear on one thing here, which is that every single time you run the calculator, no matter what event you just created and what events have already been kind of accounted in the calculation, you're running through all of them. So at this point, the user has decided to update their subscription, and the creation literally might have been a year ago, but the calculator is going to run through all of them from the beginning of time to now. This comes in really handy later. So, you've got a subscription service, you're making shipments, right? You're gonna record that somehow. You probably wouldn't record it as an event, right? It's not a subscription event, it's probably its own standalone thing called a shipment. Subscription ID, and let's say num bottles, a number of bottles in this box. And this is where it starts to get a little tricky, right? Because we've written it saying, well, we actually want to do events attached to the subscription, sort of I created that. What I decided to play with, and this worked out pretty much fine, is just to expand the definition of what is considered an event. So at the top here, you just call events 2A, and you concat the shipments. So now you have an array, and it's got a combination of different kinds of active record objects, right? It's got subscription events, and it's got shipments, and you call sort by created at, right? This is the lovely aspect of duck typing, where you don't really care what is in this array, as long as it responds to created at, and you can use it. And then you kind of loop through those certain events. Now, if shipments aren't going to respond to event type, so you need to basically say, well, if it doesn't respond to event type, I'm going to say its event type is just its class name. So in this case, you have to create a method called advanced shipment, and that's what this looks like. You've got the bottles left number on the subscription, and now you're decrementing. Somebody bought 2 bottles, then you created a shipment where you sent them 2 bottles, they have 0 bottles left. And then recurring payment is actually the opposite. You create a payment record, which is timestamped as is attached to a subscription, and maybe you have bottles purchased on it. What you can do then, when you add that, when you take care of that in the calculator, you can basically say subscription bottles left. You just add the number of bottles purchased to increase the balance. So now some of you are thinking that this looks like a lot of code and a lot of hassle. And what are the benefits of going to all this trouble? So one small thing that you get, this ain't bad, right, is you get a timestamped record of changes. You can sort of look through, you can get all the events and sort of print them out in an admin screen and say, okay, this person they created a subscription on January 1st, 4 days later, we sent them 2 bottles, now they have 2 bottles left. Another month later, we sent them another 2 bottles. Now they have 0 bottles left. And then based on our recurring billing logic, in March 1st, they made another payment for 4 bottles, and we're back up to 4. So that's nice. But what really was powerful for me is the idea of actually getting some decoupling and saving some debugging pain. This is your standard. This is what you're doing without event sourcing, right? Assuming you're going straight from the controller, which is its own question. But yeah, you're just going to make changes on a subscription and save that right to the subscriptions table. Now what you've done is you've broken this up, and what the controller does is it creates a subscription event, then calls the calculator, which then calculator gives you a subscription, and you save that to a database table. So decoupling, hassle, right? But what you get out of this, and what I found to be really powerful, is that you've basically kind of broken up the pipeline into 2 different steps. And on the left-hand side, the data is authoritative, but the code is simple, by which I mean, first of all, the subscription events are a big deal. You can't lose that table. That's as important as any other data you have in the system. But the code is actually really simple. In practice, it's really hard to get an event wrong, because it really is just like a couple of form fields a lot of times. On the right-hand side, the data is derived. In fact, it's what you're actually looking for. Most of the time, you're actually asking the subscription, what state are you in, what's your deal, right? But the code is complicated. And this is where bugs show up, right? So it's nice that the data is derived here, because it's going to give you flexibility when you fix bugs. Let's give you an example. Let's say you want to have an active Boolean on the subscription record. It's pretty easy, right? You add a migration to create an active Boolean on the subscription table. Let's say you're going to define active as number of bottles remaining is greater than 0. So you add that, and then you got to add it to the calculator, right? Let's say when you're first created, active is true by default. Then when you create a shipment, when you decrement the bottles left, you got to check to see if the bottles left is 0 or less, you're now inactive. And if the payment takes you back over bottles, up to more than 0 bottles left, active is true. Who here sees the bug? Anyone see the bug?
Nested if statements.
No. Come on. This is the bug right here. And in fact, here's what's going to happen. You're going to push this out to production. You're going to calculate the active field and everything. And then you or someone else is going to realize, wait a second, because of recurring billing scheduling, we send them their second box on February 5th. Bottles is 0. But in fact, now bottles left is 0. But in fact, their bottles left will stay 0 until March 1st. That's not inactive. That just means we haven't built them yet, right? Are you actually going to say that for a, 18-day period, every 2 months, they're going to be inactive? Like, what the hell is that? So you heard, let's say we want to fix it. This is what I'm talking about. Recurrence logic sucks. It's like really hard. It's very easy to get the stuff wrong the first time. So let's say instead we make the definition of active more sophisticated. And we say, really what it is, because everybody's a recurring user. The last recurring payment was successful, or there have been no recurring payments. And the only time you can be inactive is when we tried to rebill you and the billing failed. Like that's like a suspension, we got to send you an email, blah, blah, blah. Okay, so that's actually pretty easy. Again, on creation, active is true, right? And then on payment, and only on payment, let's say payment has a success Boolean, we can basically say active is either true or false based on what the payment was. That's all. So that's awesome, right? You push out code, someone told you there was a bug, you fix the bug, you feel good about yourself, until then you realize, oh, wait a second, there's like X subscribers in the system, in the production system now, and their data's shit, right? And now you're in the really crappy situation of having to fix bad data and just feeling like an idiot. And this always sucks. This always sucks. You're in there on Rails console, taking fucking half an hour to send somebody in customer service a hit chat message saying, these 42 IDs are broken, I think. Right? You don't even really know, except for if you did it this way, because event sourcing gives you this great flexibility. Again, if you did it this way, you're just fucked, right? But event sourcing event sourcing rescues you from this situation. You change the calculator, which fixes the source of the bug. You deploy the code, and you test pass, all that good stuff. You deploy the code to production, and then you rebuild all the subscriptions, every single one. Which sounds pretty aggressive, right? All of them? But here's the thing. We've already established that the code, all the bugs, everything buggy about this lives on the right side of this line. The bug was introduced in the calculator. It wasn't because the events were created incorrectly, because events are easy to create, right? It was created in the calculator because the interpretation of those events is difficult.
right? And then the buggy results were saved in the subscription table. So everything on the left-hand side of that line is fine, and it's only things on the right-hand side that are broken. So you fix the code by fixing the calculator and deploying it to production. And now, because the calculation process is deterministic and idempotent, you can basically rebuild everything. And I would do it all the time. I literally had a rig test that was just rake rebuild subscriptions, not find the ones that were broken, just rebuild all of them, because you know that it's actually not worth your time to look for the ones that were broken. Now, a really, really big company with very complicated customer service remediation processes actually does want you to find that stuff, so we didn't have that problem yet. But even so, it's really great having this like sense of security of just saying, you know what, like, I don't even have to go hunting for this. It's not worth my time. It turns out that this is where a lot of the bugs were. These are all Booleans that I ended up adding: active, automatic rebuild, canceled, canceling, which had to do with recurrence, and if your payment was going to buy you more than one box worth of thing at a time, held, suspended, all these things showed up. This, very briefly, is a description of the logic that went into every single one of these Booleans. If you can get all these right the first time, you're a much better programmer than I am. Reporting also, as a nice side benefit, is really easy. Because now you've basically built this very reliable sense of calculator that can basically say, you know what? And by default, up until now, we've basically been running everything up to now, but it's super easy to say, you know what, just run it until the last event time. If you want to know if a subscription was held on a specific date, just tell the calculator, run until that date and then stop. This is a pretty powerful pattern, and it turns out event sourcing is everywhere. It's in your checkbook. All financial systems use event sourcing. Every single financial account that has ever affected your life started out at the number of 0, and then it was accumulation of transactions over time that changed the number. In fact, that is so rigorous that some of you may or may not know this. In corporate accounting, when you file your taxes, and then you realize there's a mistake, there was a mistake in the previous year's taxes, hopefully it was a mistake and not a mistake, right? But if you realize there's something you have to correct, you don't get to go back to last year. You make a new thing. You recognize a new kind of charge based on something, an analysis of the previous year. Source control is also event sourcing. You start out with an empty directory of source code, and then you add files, you change files, you move them, you delete them, and that's part of the reason that Git is so powerful. Because once you learn everything that's inside of Git, you can branch, you can merge, you can cherry pick, you can emit, you can stash changes, you can email them around as patches. And so again, it's more decoupling, right? Like if you were somebody who, actually, now I'm really curious, who here uses Subversion or another, like a non-distributed source control? Wow, you have no idea what you avoided. So I'll tell you, as somebody who had used Subversion and then made the transition to Git, at first the learning curve was really intense. I was like, why is it all these different things? And it was just really annoying. But then you realize, by giving you all this granular control about all these transformations, right, on these events in your source code, you have so much more control over how your code works. So there's some downsides. Let's go over it. First of all, it's definitely more decoupling. It's more code. I don't think there's anything you can do to get away from that. So there's a little more startup time in terms of the code you write. In Rails, we have a very funny problem, which is basically that Rails is built, so much of Rails is built around a single record and updating it in place. The CRUD operation is so holy in Rails, right? And even to the extent that if you look at a form, like if you know a website, if you know a website is a Rails website and you view source on its form, you can guess what its database schema looks like, and you'll be right like 75% of the time, right? So you've got your view, or maybe your setting models left. We've already discussed you don't want to be setting that directly without an event, right? Routing has put, and it wants you to do updates. Controller wants to do updates, and then Rails just gives you all these really great, super convenient update attribute methods. If I'm writing event sourcing in Rails, there isn't a really great way. I mean, I may experiment with this, but I don't know if there are really good ways to prevent somebody else from coming in and not knowing what they're doing, not knowing the paradigm, and they're just calling update attribute, and then like 2 weeks later being like, what's going on? These updates are not persisting, right? And idempotency requires a certain amount of discipline. Inside this calculator, you can't do a lot of convenient things. You can't send emails, you can't initiate payments, you can't fire analytics events, because you literally you're gonna run it too much, actually. It's easy to set it up though. It's best to set it up so you just you never hesitate at running this calculator. You just, whenever you have any doubt about whether or not something changed, you just run it. But I think that's okay, and I think it actually works pretty well with the world of sort of service classes, which I also kind of like, right? So you might have standalone things that are doing their own creations and also firing those emails or initiating those payments, and then all calling a calculator at the end. And creation, so creation is strange. Let's go back to this. This was the creation slide I showed before. You call subscription new, which is to say you don't save it in the database, you instantiate a Ruby object. And then you call subscription.events.build, which is another instantiation. You now have two active record objects that are linked together, and neither of them has been saved in the database. Now, if you are super familiar with how active record association logic works, you know that this will work. Because what happens is when you have these two new things and you call save on the containing model, it will save it first, and then it will like dig through its associations and find anything that needs to be saved and save. But by the way, I can't even tell you what happens if that second save fails. I don't actually know. It's complicated, and it feels unsatisfying that it's so bound up, right? Like, where is the creation logic? What is the subscription's responsibility? Who owns this problem? So there's another way you could try to do it, and I experimented with this later, which is, what if you could get a subscription ID somehow without getting a subscription, and then you would create subscription event.create, and you would just put the ID in it. You can do this, by the way, right? Rails doesn't stop you from entering subscription ID if it's not attached to a subscription, and then you could maybe modify the calculator so it would also take the ID instead of just a subscription event, and then you'd save it, right? But now you have to figure out, can you get an ID of a database record that hasn't been created yet? And it turns out that you can, depending on the database, with database sequences. So who here does not know what a relational database sequence is? Who here has not heard of one? Okay, I'll walk you through it anyway. Most of the time when you do an insert, when you don't specify the primary key. And that insert will do two things for you. It will get a unique primary key, a key that is guaranteed to be unique for you, and then it will insert a row with that primary key. So you kind of have uniqueness, and then somehow the driver will return the primary key of the thing that you just inserted. It doesn't have to be done as one. If you're using Postgres, SQL Server, Oracle, I don't know, MySQL doesn't support this, SQLite doesn't support this. But if you're using Postgres at least, you can do this by getting a unique primary key first by calling select next val subscriptions ID seq, which is not super user-friendly, but it works. And basically that increments an internal sequence and returns you that number. No one else will have that ID. And then you can say insert into subscriptions, assuming you got 4, 5, 6 back from the sequence call, you can put that manually in the insert and it'll work just fine. What's funny, by the way, this comes in really handy if you're like doing a data warehousing thing and you have to prepare these giant transactions and you want to have an ID wrapped up with a bunch of other inserts at the same time. It's not that commonly needed in a Rails app, but I ended up wanting to use this. So instead of this, we have this. And this will work just fine. You have the SQL. Rails doesn't really want you to do this. It doesn't support sequence calls out of the box because it's not a lowest common denomination database function. But you can basically say subscription ID equals con, select one, SQL, next val 2i, right? So now you have an ID. It's guaranteed to not belong to anybody else. And you can set the calculator up to say, okay, look, I don't have a subscription with this ID yet. It's time for me to create one. Or build one, excuse me.
Francis, are you doing all of that in case there's an error in the middle?
Sorry?
You're doing all of that in case there's an error in the subscription event create, so you don't have to create.
No, I'm doing all of that. The question is if I'm doing all of that in case there's an error in the subscription creation. It's really not that. It's really just that it's conceptually really weird, I think, to have the creation code be so delicate. Like, I feel like that code, which I got to work the first time, but I feel like it was just not very resilient. It would have been really easy to get it wrong. It would have been really easy for someone else to come along and have to do a different kind of creation and get it wrong. So this is actually much more robust. You get an ID, so the first 3 lines are weird, but once you get an ID, a lot of this I think is much simpler. You have to wrap your head around the concept that like this ID might not exist yet. Yes?
Is that ID reserved? If another record gets saved as you're going through the creation process, will they be using that ID or jump to that?
The question is that ID reserved? And the answer is absolutely yes. That's the essential, that's all the sequence does. It increments monotonically. And by the way, what will happen sometimes, like in data warehousing apps or whatever, is you'll have processes that get these IDs back, and then they fail for whatever reason, sure, fine. And then you look later, and the database actually has numerical gaps. But it's fine. It turns out gaps don't matter, right? So yeah, that's absolutely what it does. That's the only thing it does, really. It's just like, I'm the next number on this table, or yeah, it's guaranteed unique. Jesse?
So is the idea now at the bottom that subscription will either return a new object or what, the existing one? Like,
Yes, that's right. You'd have to modify the subscription calculator that it looked up for an existing subscription based on that ID, or build one. Also, by the way, I'm not showing this, but if you call subscription.new ID 424 or whatever, that actually works. When you save it, Active Record will put that in the insert statement, so this will work. There's another weird thing about this, which is associations to other models. Some people, by the way, when they write event source apps, everything is event source, and it's this giant river of crazy events, which is awesome, and I don't have a ton of experience with that, though it is awesome. But let's imagine we have, if you live in a hybrid situation, which might be how you end up starting out with this idea, you have to think to yourself, which models live outside this concept, and which models kind of have, which are event source, and which are sort of the more old-fashioned Rails things. Because Rails models don't give you a great way to know if they've been updated, really, or what has been updated. Let's say you've got this subscriptions have users, right? And let's say we add a field to the subscription called user hair type, which is just the hair type of the user that you've stored on the user record. I don't know if any of you can see sort of where this gets tricky. You have to ask yourself hair type when, right? The user was created, let's say the user was created a year ago. And let's say the subscription was initially created a year ago. Right? And then sometime in the last year, they came along and they changed their hair type. And now if you run the calculator, what's going to happen? It should be the exact same thing. It shouldn't update to the new hair type. So what's up with that? Are there ways to solve this? I tried a couple of things. They both worked okay. One of them is very simple. You just take the user as it is now. At the time of creation, in the code that creates it, you grab the user and you just dump it as JSON. So that no changes will not be recorded with that event. You kind of freeze the state of that user at that time. Another thing is you could actually use paper trail, which is another way of doing the same thing. If you make a user have a paper trail, then in the calculator you can say, let me get the user at the time that this event was created, and I'll use the hair type after that. And changes in business logic get tricky, but I actually found that this is one of those things where it's hard to do either way, and I think it's actually a little easier to do in event sourcing, but what you have to do is you have to be really explicit. Let's say you have cancellation policy. Someone prepays and they buy a bunch of shampoo and they didn't get all the shampoo and then they want to cancel. Do you refund them the prorated portion of their unshipped shampoo, or do you just say, screw it, you bought up front, tough luck, right? What if you end up changing that? You can basically say, you can effectively hard code either in Ruby code, or you could actually store this in data if you wanted to be super precise about it. You could basically, starting on this date, you change the policies. That's all, right? And in fact, this ends up actually becoming a pretty common practice. Like you'll see this in accounting models all the time, where they're like, oh yeah, starting now, we change how we recognize this kind of expense, and you have a very clear line that you draw. So the big trade-off really is accuracy versus iteration speed. I think this is a lot more code. I don't think it would be appropriate for everything. But I've worked in a lot of e-commerce sites over the last couple of years as I've been consulting. And I feel like e-commerce, there are a lot of sites where basically the revenue per piece of data is so high that it's probably a good idea, right? Like if you're building a dating app or a photo sharing site, and 1 out of 1,000 users has their photos dropped, who cares? They didn't pay you any money anyway, right? So it's like, okay, it's probably just not worth that, solving that problem. But if you're actually literally taking $200 from a person, and then once in a while their order gets totally messed up, and customer service is stressed out, and they're calling you, and you're stressed out, and you literally don't know what happened. No matter how smart you are, the data's been lost forever. This is the time to think about something like this. As for what's next, I am thinking about, I haven't even really started working on this, but I'm thinking about making a gem that works inside of Rails, calling it an event source model that boilerplates some of the stuff that would create migrations and the different models and the calculators and blah, 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 and then give you some base calculator logic. If you think you might be into this, please let me know, because I have questions for you as to how you want to use it. But otherwise, yeah, I just wanted to share this idea. It was super useful to me, and it might be useful to you. And thanks. Questions or comments? Yes, sir.
So you had this example of business logic changing, and so if date was past something and then you use different policies, right? So do you end up having, well, you never get to delete code, right? So you have all this logic that stays around forever. I mean, is that one of the side effects there?
Yeah, the question is basically if your business policy is changing over time and you end up having situations where you basically never get to delete code, I would say yes, I think. And I think that that's probably fine. It's ultimately not that much code if you modeled it okay. I would also say that like, you know, there are probably, when people talk about some very large systems, then they'll do stuff, and this is usually driven by sort of the size of the data, but they'll say stuff like, oh, you know what, screw it. Anything older than 3 years, we're just going to archive it, snapshot it, and not worry about how it got that way, right? Presumably, records, so maybe if it gets to be just painful and just terrible, then you can just sort of snapshot and say, okay, we're starting from this, but this is day zero, right? Because presumably, like a record that is 3 years old, even if it was a bug, you're not finding it. Like that person already hates you. You can't get them back anyway, right? But yeah, there's definitely a sort of a trade-off. I mean, there's kind of the dream of, oh, we start from the beginning of all time and run everything, but maybe it's just not what the hassle is.
That's how the Redis AOF log works like that. Like it stores all the operations that happen, and then periodically it will compact all the operations into a snapshot and store more operations on top of that.
And I think
so it doesn't grow unbounded.
And I think part of that is like there's a Redis replication has to take replication into account, right? Isn't there like a thing where I don't know much about this, because that's a big part of it too. Is like transactional stuff in these like NoSQL data stores or whatever, or really any data store, is like replication is a gigantic use case for this stuff. So you can sort of see like when you get a bunch of different nodes of a cluster, they all kind of have to resolve to see who's caught up to all the events, and then Jake, do you have a question?
I was just going to say, on the sequencing thing, if you have the ability to use UUIDs as your primary key, it makes that a lot nicer.
Yeah, that's a good point. Right, so yeah, UUIDs are good too. I've played with those too. Very nice. Yes, sir.
Actually, this is not a question, but more of a testament to what you're discussing. So I worked on building a doubling tree accounting in a cloud platform that's called Subledger, that Brian's actually wearing that shirt right now, shameless plug. One of the things that we learned was that approaching it the way you're talking about, like all people oftentimes try to approach data modeling from like a noun perspective, but we approach it from more like think hopscotch. So you're like constantly having additive data. And we realized that if you don't have to go and update anything in your data, not only can it be distributed very well, but it also can like sit on any data store in any paradigm, like it runs on DynamoDB, whatever. And you learn a lot more about your data and also how you're doing it. So I totally subscribe to that. And you said starting from zero and moving forward, like I've had the least amount of problems with data migrations, warehousing by approaching it from that manner. So kudos to that. It definitely works for sure.
Looks like you had a question, yes.
Yeah, so how do you go about like charging the customer and making sure that like if the charge failed or went through that data was recorded accurately?
I didn't really show slides of that. The way I would handle that stuff is basically how do you initiate charges, how do you handle like incorrect charges and kind of do the business logic. A lot of that stuff is like done by service classes. It's like how I like to do it. Often fired by rig tasks or like cron jobs or whatever. The notion really is that you have work on the outside that's adding events into the system. But the actual resolution of those events, like what those events, the final implication for the subscription is not the service class's job. So we'd have a rebuilder, and the rebuilder would basically say, okay, based on, we would always just set like rebuild dates or things like that on the subscription, and you can build all these fields if they're just convenient to have there, you know. And we say, based on your rebuild date, oh, we're X number of days from whatever, we're gonna rebuild it, and we're gonna make an attempt and have our branching logic. If it's successful, we create a successful payment. If it's a failure, then we kind of like record a failed payment and send you an email. And of course, then you have like usually like your sort of like steps of like, first you try day 1, you send them emails, then you try on day 2, then you try on day 5 or whatever, and then at a certain point you say, okay, whatever, then I'm coming back. Those happen outside the calculator anyway. And this doesn't make that any easier or harder by itself. Like billing logic is still just like a lot of work, really. And like that part of recurrence logic. But at the end of the day, what you can do, what does help you is the notion that the subscription can add these fields that sort of help you figure out when to bill next. And that stuff, which a lot of that is like the core of why recurrence is difficult. that you can really iterate on and kind of change and keep redefining, knowing that any bugs that you get, you can just sort of fix them along the way. Any questions?
How do you handle the side effects, like sending emails?
The questions of how you handle side effects, they're all having instant responses. Can't do them in calculators. That's basically it, right? Like it could be done there, it could be done in a controller if you want to go old school, you know. But generally, like the calculator, you have to be able to safely call it all the time for any reason at all. It's not that different from like, I mean, it's any kind of, it's a cache update, really, right? It's similar to like a redraw in Ember or something. You should just be able to do it wherever the hell you feel like it, right? And have like no concern about having a negative side effect. That's the point. Any questions? Yeah.
Have you had any trouble with schema changes? I've run into some problems where something simple, you want to rename an attribute in a table.
In this example, would that be in the event or in the subscription? Okay, so the question is, have I had any problems with schema changes? And actually, I would say no. The reason being that, I mean, schema changes, I guess, are always hard, but it's a lot easier because you can always sort of rebuild when you've deployed it. Now, of course, like if you're, so what's the easy example is you're renaming it to column, which you're not even going to ask about because that's like so obvious. It's not that interesting. The hard example is like, let's say you had a Boolean field and the concept doesn't even make sense, right? It took you a while to figure this out, and you're actually going to delete that field and replace it with 2 other fields, and then you've got to build the subscription job. That is kind of a migration problem, right? Because if you delete that column, there's code living on it. Maybe the rebuild job takes like 5 minutes. Is that scheduled downtime? Blah, blah, blah. It's not that different from other kind of migration problems. You could do it in stages. You could add the 2 new columns, do the rebuild, and then have like the second phase kind of deploy. So it doesn't save you from that, but what it does help you do is basically keep redefining things. Like, I never got into a situation with this model where there was a Boolean on the subscription, and I was like, God, I just hate what this is called, or I hate the way we defined it, but I can't fix it because I don't know what I'll lose. Right? Because there's nothing in there that is important, actually. It's all coming out of the calculator. So you're very free to be like, fuck it, I'm redefining this whole thing. This concept sucks. I'm deleting this field. I'm creating 3 new ones. I'm putting it in the calculator. I'm just going to run it. I'm going to populate it, and that'll be awesome. Other questions?
Do you generally think of the stuff, piggyback on that, do you generally think of the stuff inside the events as private to the calculator?
The question is, do you generally think of the stuff inside the events as private to the calculator? And I would say generally yes, yeah. The events are, they're very low level. They're not very readable. They're not super convenient. They will change over time, by the way. Once in a while, you'll end up redefining an event. Like, oh, you have to add this new field. The calculator, by the way, does have to check. Like, oh, this thing wasn't here from the start, but once it starts showing up, I'm going to treat it this way. Yeah, and so it's very like, it's got a bit of mess in there. But yeah, it would be really rare that you would expose that directly to like end users in any way. You do want it to sort of be kind of contained in the subscription. The term for this, by the way, is projection, right? Like the subscription is a projection. It's some sort of like calculated form. You can even imagine pulling this into like an Elasticsearch cluster if you wanted to do some other stuff with that. Other questions?
One last question.
Okay. Oh, yeah.
In addition to kind of rebuilding the entire cache, would you ever consider just like recalculating everything and checking against every record in the cache and then being like, wow, some of these don't match. I must have a bug.
Well, the thing is, that would be a super rare bug. So the question is, do you ever consider rebuilding everything, not saving it, comparing it to what's already in the database table, and seeing if there are discrepancies and saying, I must have a bug? I guess if your code was super complicated, you might have to worry about possible, like that implies that the calculator isn't actually deterministic, that it had a different result running at a different time, assuming there's no new events since, right? That which is always kind of a question mark. But for the most part, it's just not, if you do it right, or in my experience, it wasn't that interesting of a problem, you know? Again, I think maybe the more common use case would be if you were at a very big company that had very like explicit like fixed strategies where you had to actually find who was affected by a bug so customer service could proactively reach out to them, then you would probably, that's how you do it.
Okay, thanks.
We actually do gold master testing at Code Climate to check that our analysis algorithms don't change unexpectedly given a commit in our analysis. Like, oh, if we make a change to the analysis and it's not supposed to change in the analysis result, it actually is pretty hard to do that because it's super complicated. So we will save a snapshot of the answer persisted on disk, and then we'll rerun the new algorithm and can just compare every single field to make sure that it doesn't shift unexpectedly. It's not event sourcing, but because we're in one of those cases where we need to make sure it's deterministic, and like if it's not deterministic, everything explodes.
So it is one Git repo analyzing another Git repo, right? So it is kind of event sourcing, or you could say it.
Yeah, right. Yeah, I guess that's true. I didn't even think of that. All right. Thanks, Francis.
Thank you, guys.